order search tree. So what you have given the root of the binary search tree. You have to rearrange the tree in order. Okay. So that leftmost node in the tree is now the root of the tree, and every node has no left children and only one right child. Okay. So you are given a root of a tree and you have to traverse in order. Okay, so what is in order? So in order is basically you will traverse first the left part. Basically from here you will go to all the left. Then you will process your data, and after that you will traverse the right part. So it's basically left, data, right. There are two other traversal also, which is pre-order and post order. But in pre-order it's like left, then right, then data. In post order it's uh, sorry, in pre-order it's like data, left, right, and in post order it's like left, right, data. And in order we basically process left part first, then we process the data, and then we solve the right part. Okay, so what you have to do, you have to traverse the in order way, and after that you have to remove all the leftmost leftmost node in the tree is now basically the root of the tree. So as you can see, this 5 3 2 1, this will be the root node, and only right elements will be there and no left element. Okay, so let's understand with an example. Okay, so we have given this tree. Okay, so what we can see, this is our root. So we will traverse the left part first, so we will go in this direction. Then basically we have to do in order, and in order it's basically left, root, let me write on root, and then right. So it's like this. So we will call the left part. Okay, till whenever we reach to null, we will only call the left part. So we'll call the left part. After this this is a null, so we just come out here. So now we process our data. So now comes call to data. Okay, so what we have to do, we have to make this as a root node. Okay, so we will make this node as a new node, so we will make one. Okay, after this what we will do, we will call its right part. Right part is null, so we'll just roll back. So we come at here. Then after this this call complete for left, data, and right. Now the left call rollbacks. Okay, so it will return its output. So another call will come here. Okay, so now you have to do some processing on data. So what we have to do, we have to make this root node right child. Okay, so we'll make this as 2. Again we'll call its right part, so it is also null. We just return from here, and we will call its again parent root. So we'll roll back here. We will do the data processing. So now this will be the right part of this. Okay, after this the call will go to the next right children. So right will do its call, so right will call its left part, so which is null, and from here we also return. So now we have to do some processing of our data. So what we have to do, we have to make it new child, which is 4. Okay, then what we have to do, the call will go back to again to 3, and it will call again to call back to the parent root, and now you have to write 5 after this. Okay, in the similar manner you have to solve this right subtree also. Okay, so this will be like 5 6 7 8. Okay, now I hope like the question is clear to you. Now how we can approach our question is, so first step is pretty clear, we have to do in order. Okay, then what you can see, this is a skew tree. Okay, skew tree is basically in only in the, and it's a right skew tree basically. The tree which is only containing only one children, either only in one direction, either it is left or either it is in right. So as you can see, this is skew right tree. Okay, so what we can do, we have to traverse in order. Then after this what we will do, we will basically take it as a linked list. Okay, so this we will treat it as a linked list, and we'll say this is our head, and we'll take a tail pointer also at the start point, and after this we'll insert all the elements. So when the second come, the tail dot next will point to the second tail dot, we will just take next to right. So next is equivalent to right. Okay, so we'll do tail dot right, which point to 2, and we'll move our tail head here. Similarly, we will go by down. So when 3 is come, we will point it tail to next to this pointer. So this 2 is next right, and tail will come at here. And finally, we just return our head. Okay, so head will give us the top root node, which is the leftmost, you can say, root node in our original tree. Okay, I hope the approach is clear to you. So let's write the code for this. So what uh, we need, you can say, tree node head, and we can say tail. Okay, we'll initialize them, head equal to null and tail equal to null. Okay, now call goes to in order. We'll pass the root node, and after that we just finally return our head. Okay, so this is our main function. Now let's write the logic for in order. So which is in order. The return type is void because we don't have to return anything. Tree node. Okay, so in order, it's basically, you can say, left data and then right part. Okay, so we'll call the left part first, node dot left. Okay, the semicolon. After this, we'll do processing over data, and finally we call the right part in order, node dot right. Okay, so what we have to do first, we have to create a new node. Okay, node equal to new node dot value. Okay, it's and the class is of type tree node, so node tree node. Okay, what we have to do after this, we have to check whether our head is initialized or not. So let's say if head is not initialized, we can't make our tail node next to point to this. So what we will do, if head equal to null, we'll do something, else we do something. Okay, if head equal to null, we point both head equal to new node and tail also point to new node. So this is our basically a first node that is inserting our right skew tree. Okay, after this, what we have to do, we have to just, in the else condition, it's like tail dot next equal to new node, and we update our tail to new node. Okay, I think we have covered the main logic. Okay, base condition is left. So what is that? If your node equal to null, you just return from there. Okay, I think we have done with the code, so let's run it. Okay, there is some mistake. Okay, so it's basically a semicolon. Okay, one more mistake. So this is not tail dot next, it's not a linked list really. So it's just a tree node, so it's, and we have to point the right node. So this will be tail dot right equal to new node. So let's run it again. Hope it will run. So this is accepted. Let's submit it. So our code is submitted. The time complexity is like you will traverse all the nodes in the tree, so that is order of n, and similarly the space is also order of n because you are creating a new node out of that. Okay, hope you like it. Thank you for watching my video. Thank you.